On the July 18, 2025, an update was pushed to a niche corner of the internet. There was no press release, no flashy marketing campaign, no keynote presentation from a CEO in a black turtleneck. It was a simple software update from a community-driven project, a project most of the world had never heard of. And yet what it contained was a shockwave, a tremor in the force that should and will make billion-dollar corporations very, very nervous. This is not a story about a simple software update. This is the story of a revolution. It's called Hydream E1.1, and what it can do was, until last week, considered by many to be impossible. For years, the world of AI image generation has been a battle of giants. Adobe with its corporate safe Firefly, Midjourney with its beautifully artistic but ultimately closed-off walled garden. These tools are powerful, but they operate on a simple principle. You pay, you follow their rules, and you get a pretty picture. Then, this happened. Look at your screen. This is a movie poster. The text clearly says Joker. Now watch. With a simple one-sentence command, the text now says clown. This isn't a Photoshop job that would take a graphic designer an hour. This was done by an AI in 12 seconds. Look closer. The AI didn't just paste new letters on top. It understood the gritty, painted texture of the original. It understood the lighting. It understood the perspective. It hallucinated, with terrifying accuracy, the wall behind the original letters, and then painted the new ones on top as if they had been there all along. Let's try another. Here is a photograph of my own grandfather, taken 60 years ago. It's torn, it's faded, it's covered in scratches. Running this through other professional restoration tools, you get a cleaner image, sure, but you get a waxy, plastic-like skin. The soul is gone. With Hydream, we give it one command: restore this photo, fix all damage, and preserve the subject's character. The result? The scratches are gone, the tear is gone, but the life is back, the tiny wrinkles, the texture of his tweed jacket, the light in his eyes. It's all there. The AI didn't just repair the image, it respected the memory within it. This is the story we are investigating today. This isn't just about a new, powerful, and completely free tool that has suddenly appeared. This is about a fundamental shift in the balance of power. It raises a series of critical questions that we will answer in this report. How did a decentralized, community-run project create something that rivals, and in some cases, surpasses the technology built by corporations with nearly unlimited resources? What is the secret code, the unique architecture under the hood that unlocks this new level of capability? And most importantly, what does it mean for the future of art, truth, and creativity now that the power to manipulate reality with this precision is in the hands of everyone? This isn't a tutorial, this is an investigation, and it begins not in a lab, but with an idea, the idea of open source. To understand the Hydream shockwave, you first have to understand the rebels who built the world it lives in. This story doesn't start with Hydream itself. It starts with the digital equivalent of the punk rock movement. It starts with the philosophy of open source. For decades, the dominant model in technology was the walled garden. Apple, Microsoft, Adobe. They built beautiful, polished ecosystems, but they owned the walls, the gates, and the keys. You were a guest in their world. The code was secret, the roadmap was secret, and innovation happened at a pace they dictated, but in the shadows, another model was growing. The open source movement, a philosophy built on a radical idea that collaboration, not competition, is the fastest path to innovation, that by sharing code freely, a global community of developers could build things faster, better, and more securely than any single corporation ever could. It gave us Linux, which now powers the majority of the internet. It gave us Android, which dominates the mobile market. It was a proven model, but for the longest time, high-level creative AI remained firmly behind corporate walls. It was too expensive, too complex, requiring massive data centers and teams of FADS. The first crack in that wall appeared in August of 2022. That was the month a company called Stability AI did something unthinkable. They released Stable Diffusion to the public, for the first time. A truly powerful foundational model for generating images was not just a service you could rent, but a tool you could download, own, modify, and run on your own machine. It was a declaration of independence for the creative AI world. Suddenly, innovation wasn't just happening in corporate labs. It was happening in bedrooms, in university dorms, on Discord servers, and on GitHub repositories. An explosion of creativity followed. New interfaces, new techniques, new models trained on specific styles. The community was moving at a speed that was simply dizzying. Out of this Cambrian explosion of innovation, one tool began to gain a reputation among the power users for its unparalleled flexibility. Comfy UI. Unlike the simple text prompt and button interfaces of Midjourney or Firefly, Comfy UI looked complex. It looked like a flowchart, a series of nodes and connectors that you, the user, had to wire together yourself. For the casual user, it was intimidating, but for the serious artist and experimenter, it was freedom. It meant you weren't limited by what a company thought you wanted to do. You could wire up your workflow exactly how you wanted. You could mix and match models. You could chain processes together. You could build your own custom creative engine. Comfy UI wasn't a product. It was a philosophy made manifest. It was a declaration that the user, not the corporation, should be in control, and it is on this foundation of rebellion, on this platform built for ultimate control and customization, that the seeds of Hydream were planted. The developers behind Hydream weren't trying to build a polished, user-friendly product for the masses. They were a part of this community, and they were trying to solve the hardest problems that even Stable Diffusion struggled with. They weren't asking, how do we make a prettier picture? They were asking, how do we give an AI a deeper, more fundamental understanding of reality? How do we teach it to read, to reason, and to respect the details of an existing image as much as it respects the user's text prompt? They were a small, decentralized team, collaborating across time zones, driven not by profit, but by the shared obsession of cracking a code. Their work stands in stark contrast to the corporate approach. While big tech companies were focused on building safe, predictable, and marketable AI tools, the open-source rebels were on a quest for raw power and capability. They were willing to be messy, to be complex, because their goal wasn't to sell a product. Their goal was to push the boundaries of what was possible. And with the E1.1 update, they didn't just push the boundary, they completely redrew the map. So how did they do it? How did this small band of digital rebels, working in a decentralized fashion across the globe, build a tool that could see, reason, and create with such terrifying precision? The answer isn't a single invention. It's a symphony of different, highly specialized AI models, forced to work together in a way that has never been done before at this level in the open source space. This is where we go under the hood. This is where we unlock the code. To understand Hydream, you must first abandon the idea that it is a single AI. It is not. Instead, you should think of it as a small, elite committee of digital experts, all working on your project simultaneously. Each one is a genius in its own field, and together, they achieve results that none of them could achieve alone. The first member of this committee is the art historian. In technical terms, these are the clip models. For years, clip has been the backbone of image generation. Its genius lies in its ability to form a deep connection between visuals and words. You can show it a picture of a dog, and it knows the word dog. But it's more profound than that. It understands abstract concepts. It knows what a sad dog in the style of Van Gogh looks like. It has studied billions of images and the text used to describe them. It has an encyclopedic knowledge of art, photography, and the visual world. Its job is to look at your image and your prompt and understand the aesthetic connections. It is the visionary, the expert in style and substance. But the art historian, for all its knowledge, is not a great conversationalist. It understands concepts, but it can struggle with complex, nuanced instructions. This is where the second, and perhaps most revolutionary member of the committee comes in, the interpreter. This is the large language model, or LM. In Hydream's case, it's a team of them, including variants of Llama and T5. This is the same core technology that powers ChatGapt. Its expertise is not in images, but in language. It is a master of grammar, syntax, logic, and most importantly, user intent. When you write a prompt, the interpreter doesn't just see a bag of keywords, it reads the sentence. It understands clauses like change everything except the person's face or make the car look like it's been driven through a desert with a light coating of dust on the windows. It understands conditional logic and complex relationships. Here is the magic. In older systems, the user would talk directly to the art historian. The user would write a prompt, and the clip model would do its best to interpret it. In Hydream, a new workflow was created. The user talks to the interpreter first. The LM takes your complex conversational prompt and breaks it down into a hyper-detailed, explicit set of instructions, a technical brief that the art historian and the main image generator can understand perfectly. It's a closed-loop conversation. The LM acts as a universal translator between human intent and machine execution. The diffusion model starts to paint the image, the art historian checks the painting against the detailed brief, and the interpreter ensures the logical constraints of the original prompt are being met. This loop of interpretation, creation, and verification happens hundreds of times a second. This committee structure alone makes it powerful, but it doesn't explain its surgical precision. It doesn't explain how it can change a shirt without altering the wrinkles on a person's face. For that, we need to understand the second major breakthrough, a philosophical shift in how the AI treats reality. Previous models had a fundamental problem. They were fantastic dreamers, but terrible listeners. They excelled at creating new images from scratch, but they had little respect for the pixels of an existing photo. If you asked them to do something simple, like remove a person's glasses, they would often regenerate the entire face, resulting in a new person who looked vaguely like the original. The AI's creative impulse would overwhelm its instruction to be precise. It would bleed its changes across the entire image. Hydream's architecture introduces a core principle of fidelity through a clever implementation of a control mechanism known as image CFG, or image classifier free guidance. The AI is forced to constantly reference the original photograph as a ground truth. You can think of it as a set of non-negotiable rules. The AI is essentially told by the system, I want you to be creative. I want you to follow the user's new instructions, but you are forbidden from contradicting the core, unedited facts of this original image. The structure of this person's nose is a fact. The way the light hits their cheek is a fact. Do your work, but do not violate these facts. This principle of fidelity, this enforced respect for the original image, is the secret to its precision. It stops the creative bleeding. It allows the AI to perform targeted, surgical edits rather than just washing the entire image with a new creative idea. It's the difference between a painter and a photo retoucher, and Hydream is architected to be both. So we have the committee of experts led by a master interpreter, and we have the guiding philosophy of fidelity to reality. This creates an AI of immense power and precision. But this also creates an immense computational footprint. This kind of multimodal, high-fidelity processing should require a server farm, a supercomputer. So how is it possible that this is running on a standard gamer's PC in their bedroom? The answer to that question is the final and perhaps most important piece of the puzzle, the democratization of power through a process called quantization. All of this power, this committee of AI experts talking to each other, is based on complex mathematics. The models themselves are at their core billions of numbers or parameters. A full high-precision model can take up an enormous amount of space in a computer's memory, specifically the super-fast RAM found on a graphics card. For the most powerful models, this could be 20, 30, even 40 gigabytes of RAM, far more than what is available on even high-end consumer cards. Quantization is a form of intelligent compression. Think of it like a master audio recording in a music studio. That original recording is a massive file containing every nuance of sound, some of which are beyond the range of human hearing. To create an MP3, a compression algorithm intelligently removes the data our ears can't easily perceive. The result is a file that is a fraction of the size, with almost no noticeable loss in quality for the listener. Quantization does the same for these AI models. It intelligently converts the high precision numbers in the model to lower precision numbers. It's a process that trims the mathematical fat, the unnecessary decimal points, so to speak, which dramatically reduces the model's size and memory footprint, often by 50 to 70%. And critically, if done correctly, it can do this without causing catastrophic damage to the model's creative intelligence. This is not just a technical footnote. It is the key that unlocks this entire revolution. It's the reason this story isn't happening behind an NDA at a Google research lab. It means this power is not limited to those who can afford to rent thousands of dollars worth of cloud servers every month. It means this power for the first time belongs to anyone with a decent graphics card and the will to learn. It is the final and most important step in democratizing top-tier, world-class creative AI. So there we have it, the architecture of a revolution, a team of specialists, the interpreter, the art historian, and the master painter, a guiding philosophy, absolute fidelity to reality, and the key to accessibility, the intelligent compression of quantization. We have seen the blueprints of this new engine. Now it's time to see how it performs in the real world. It's time to put it through the gauntlet.